Hey guys, I hope you're doing well. Okay, so I'm going to make a quick video here. Musculoskeletal System 5, Chapter 13. So hopefully this video is helpful. The foot has what are known as tarsals, and there are 7 tarsal bones. So if you look here, there's 1, 2, 3, 4, 5, 6, 7. The only one that you need to know for this class is the calcaneus, which is this one right here, all the way in the back. And the calcaneus is also known as the heel of our foot. Another thing that you need to know are the metatarsals. There are 5 of them. You always start numbering medially, so with the big toe, and then going laterally. So this would be metatarsal 1, metatarsal 2, metatarsal 3, metatarsal 4, and then metatarsal 5. And then there are the phalanges here. There are 14 phalanges. And if you're just looking at one single bone, it's known as a phalanx. So phalanx is the singular term. And just like the hands, there are proximal, middle, and distal. And just like the metatarsals, you start labeling most medially. So in this case, most medially would be starting at like the big toe, and then numbering going laterally. So if we're looking here, you're looking at the superior view right now. So the superior view, so this would be the big toe most medially. There's only 2 phalanxes. So this one would be, and since it's closer, it's the proximal phalanx of digit 1. Distal phalanx of digit 1. Here would be, there are 3 of them, so here would be the proximal phalanx of digit 2, middle phalanx of digit 2, distal phalanx of digit 2. Here you have the proximal phalanx of digit 3, middle phalanx of digit 3, distal phalanx of digit 3. Same pattern with all the other ones. The only thing that you really need to be careful of is the big toe, which only has 2 phalanges. Okay, so we have to look at the ligaments of the knee joint, which at first can seem super complex. But if you're patient and you stick with it, it's a lot easier than you might think. So with the shoulder and the hip joints, they were ball and socket joints. It's a little different with the knee. It's known as a hinge joint. So this is a model right here. So just like the hinge of a door, this is known as a hinge joint. So remember we learned about the condyles of the femur. So this is representing the femur, and then the tibia. So in order to stabilize that articulation between the condyles, there are several ligaments involved in that. So there's medial and lateral ones, there's posterior and anterior ones, and then there's this also funky little tendon. So it comes down from the quadriceps femoris muscle and attaches superiorly to the patella here, and the patella, remember, is like the kneecap. So the first ligament we need to look at is called the anterior cruciate.
A few moments later.
So the anterior cruciate ligament, which is also known as your ACL. Remember, this is the femur, this is the tibia, and this is the anterior view. So we're looking at the front. The ACL, the anterior cruciate ligament, attaches medially on the tibia and laterally, so if you turn it around, on the femur. So that's the ACL. Then there's also something known as the PCL, which is the posterior cruciate ligament. As the name implies, you have to flip it around and look at the posterior side. And it would just be this ligament right here. It comes right down from the femur to the tibia. So this is known as the posterior cruciate ligament. There are ligaments on the side. So this is the medial side over here, and this is the lateral side. So this is the lateral collateral ligament, also known as the fibula lateral collateral ligament, or the fibula collateral ligament. And then there is the medial one. So this would be known as the medial collateral ligament, or the tibia collateral ligament. It's a lot more fun to say the lateral collateral ligament than the fibula collateral ligament. But whichever floats your boat. So, something I didn't know, I've known about meniscuses for a long time because I've had a lot of friends. I used to play soccer, and a lot of my friends said they like tore their meniscuses or menisci and had to get surgery done. But I always assumed it was like a kind of like a long tendon. But the menisci are actually these kind of like shallow cups that form right between where the femur and the tibia articulate. So there is a lateral meniscus on the lateral side. So remember, this is the lateral side here. And then there is a medial meniscus on the medial side, which is here.
Tell us a little bit about the meniscus itself. How does it work? What does it do?
The meniscus is a cushion. It's a little rubbery gasket or a cushion. I use the term shock absorber, and we have two of them in each knee. We have a medial meniscus and a lateral meniscus. On this model, the meniscus is the white rubbery cushion that protects us. It acts as a small joint protector between the femur and the tibia. So it's the main protector from shock or impact. It's protecting us when we run, when we jump, when we squat or twist.
It seems like we're hearing more and more about meniscus injuries. Is it as common as it appears to be? And if so, how do we injure it?
The meniscus tear is the most common thing that I see as a knee surgeon and most orthopedic surgeons. It's very, very common.
Okay, so here's our beautiful, beautiful knee model. We have to, first of all, think about, is this the left or the right knee? We know that the tibia is going to be medial, so this would be the right knee that we're looking at. If you look here, you can kind of see the menisci here, forming this shallow sort of cup for the condyles to sit in. So the menisci decrease stability but increase mobility. So what's really serving to stabilize the knee are all the ligaments that are on the sides or on the front and the back. So this would be known here, if this is the patella here underneath, this would be known coming down to the tibia, attaching on the tibial tuberosity. This would be known as the patellar ligament, attaching to what's known as the tibia, which is commonly known as the shin bone. And then there's a tendon of the quadriceps femoris muscle, and it kind of attaches right here. So it's the tendon of the quadriceps femoris muscle. So when looking at the ligaments of the knee, two very common tears can occur, or common injuries can occur. So the first that everyone's probably familiar with is the ACL tear. So what happens here, so we're looking at the anterior view, this is the femur again, this is the tibia. What happens here if there's an ACL tear, the tibia moves anteriorly like this, so it goes to the front, while the femur moves posteriorly. So how you can know is you really have to grab one of these hinge models and look at the lengths of the ligaments. What's going to happen when there's a tear is that the ligaments are going to lengthen further than they really should. So what happens when you pull the tibia anteriorly, you'll notice that the ACL here is really stretching and getting really long. So that's indicative of an ACL tear. So you can see the PCL is getting shorter here when I'm flicking, but the ACL is getting really long. Conversely, if the tibia moves posteriorly, backwards like this, whereas the femur goes anteriorly, you'll have what's known as a PCL tear, a posterior cruciate ligament tear. Again, let's see if we can do this. So this is going to be the anterior view. This is the posterior view. So if the tibia is going backwards like this, you'll see the ACL. This is the PCL. It's getting long, versus the ACL over here is getting shorter. So the PCL is what would be tearing in this case. I think it helps a lot to think about these injuries and the movements of the knee in terms of the tibia. So if the tibia moves posteriorly, which is backwards, respective of the femur, we know that's a posterior tear, so a PCL tear, versus if the tibia moves anteriorly, respective of the femur, so this is going to the front, then we know that it's an ACL tear.
Okay, so there are a number of muscles that you need to know. You need to be able to identify them, and then you also need to describe their actions. So the first muscle here is the iliopsoas, and it's formed by the psoas major and the iliacus, and it's the primary hip flexor. The sartorius is known as the Taylor's muscle. It's the longest muscle in the human body. It's shaped like an S, and it has a number of different actions. It flexes, abducts, and laterally rotates the hip, and it also flexes the knee. And you'll notice that it sweeps across the anterior part of the thigh, crossing both the hip and the knee joints. The quadriceps femoris is formed by 4 different muscles: the rectus femoris, the vastus lateralis, the vastus medialis, the vastus intermedius. And the quadriceps are located on the anterior portion of the femur. And you'll notice that the names describe the location or their appearance. We remember that we learned the hamstring muscles in chapter 12. Their job was to flex our knee, to pick up our feet off the ground. The quads, on the other hand, help to extend our knee once the heel is already planted. The rectus femoris, rectus meaning straight, it helps to extend the knee and flex the hip. And the reason it has both of these actions is because it crosses both the hip and the knee joint. The vastus lateralis, it's on the lateral side. It helps to extend the knee. The vastus medialis, it's on the medial side, and it helps to extend the knee. The vastus intermedius, rather, is in the middle. It helps to extend the knee. Gracilis, it's the most medial of all the thigh muscles. It helps to adduct the hip. The adductor magnus, it's deeper, more posterior to the other adductor muscles, and it helps to adduct the hip. The adductor longus adducts the hip. And the adductor brevis, brevis meaning short, also adducts the hip. The gastrocnemius means muscle of the leg. It's also called the calf muscle. It helps to flex the knee, and it's also involved in plantar flexion of the ankle. Plantar flexion, remember, is anytime you are kind of planting your toes down and lifting the back of your ankle up. So this image on the right is actually a really good example of what plantar flexion would look like. The extensor digitorum longus, it's on the anterior leg. It helps to extend digits 2 through 5, and it's involved in dorsiflexion of the ankle, which you can imagine as kind of picking your toes up. Flexor digitorum longus, it's deep to the gastrocnemius. It helps flex digits 2 through 5, and it's also involved in plantar flexion of the ankle.
Okay, so that's all I had for the video. I hope this was really helpful. I hope you learned a lot this semester. Please feel free to reach out to me ever, since I know we're coming to a close with the semester. Feel free to use me as a resource. I'm going off to the UK, but I'm always just like an email away, so feel free to email me if you have any questions. I'd be happy to be a resource. Again, I hope you found these videos helpful. Love making them, and I hope you enjoyed this class. I think anatomy is incredible, and I think when we start thinking about human disease and the physiology behind all of these structures, it gets a lot more interesting. So you can look down and you can try to study, I don't know, the humerus or the femur, and you can bore yourself to death. But if you start thinking about the connection to human disease and human suffering, and you start putting the pieces together, I think that's when like the magic happens. Start finding what you're really interested in and just sticking with that. Again, thank you for everything. Let me know if you ever need anything.